Very good afternoon, everyone. I'm Joonhyeong Park from National Institute of Education, NTU, Singapore. I'm very happy to share some of my work today. I'm going to talk about teachers as learners, focusing on leveraging large language model for STEM assessment. So far, there's a lot of discussion, very theoretically and philosophically and ethically sound conversation so far. But this session is quite very practical. Let me introduce some of this. As we know, we are living in the era of AI, and teachers are also expected to learn how to use AI, how to interact with AI, and to use AI for their teaching and learning, and etc. And they should be a continuous learner in this era. That require their developing their AI literacy themselves. As we expected that, there's a lot more studies coming out since release of ChatGPT in 22, and there's a lot of study related to AI in professional development as well, and many of study quite focusing on conversational AI using chatbot, while there's limited studies yet about assessment system, including AI in professional development for assessment. This is what we focused on at the time. And now, I guess one of the difficult things for teachers at the time was teachers need to learn machine learning and need to learn coding languages to make it happen. However, nowadays we can utilize natural languages in interacting with generative AI. So teachers are more afforded to use generative AI for assessment. Indeed, nowadays we can easily generate any question and answers using various prompt engineering and customized generative tools and systems. It can be done also if we have better understanding of how Gen AI works, its capability, limitation, and application. If we have better understanding of how Gen AI works, then probably we have more chance to critically engage in the use of generative AI, and so that we can critically evaluating and refining Gen AI output to effectively incorporate those of ideas within human ideas. This is also applicable for assessment as well. And we also have many conversations about what is the responsible and fair use of AI. Given this mind, we can also utilize this idea for assessment as well. If we are more interested in frame of generative AI, maybe you can take a look. What this paper says about is nowadays we are more afforded to use of generative AI using human languages. So maybe we can more focus on how can shape our knowledge and how can shape our skills and attitude to work with generative AI. So we know that the use of generative AI may reduce a lot of cost and effort. As we know, one of the study investigated the time taken to generate multiple choice question by human was about 10 times longer than by ChatGPT, while the quality was the questions was comparable. Maybe there might be various attempts to fine-tuning of this work, but probably if we get some of the sufficient understanding of how to do this, then we can save a lot of time in generating question and answer for assessment. Then we can take this advantage to use more time for cater better guidance for our student. But so far, we have very not clear understanding of how well generative AI create question and answer at this moment. So in this particular study, we systematically investigate the capability of generative AI for automatic assessment item generation. If you are interested in this study, you can take a look at. This work was done based on a collaboration between NIE and Raffles Institution in Singapore, and two researchers from NIE, including myself, and there are 6 teachers from Raffles Institution, and 3 of us conceptualized this study, and indeed, they are working as a learner how to do this as well during this collaboration, and we can conceptualize together and then develop this study. Indeed, automatic item generation, this area introduced in 2010, about 15 years ago. At the time, the key technology of this area was machine learning rather than use of natural language processing or large language model. Nowadays, we after release of ChatGPT in late 2022, there are a lot more increase of this study, focusing on multiple choice question and short answer. But still, at the time, there's lack of understanding of how to creating question and answer given very complex reasoning required question yet. Indeed, there are 2 key issues in automatic item generation research area. One is how we can generate high quality items reliably. This is something we need to consider always. There are 2 approaches for this approach. One is structured input approach using predetermined template to guide item generation. The other approach is unstructured input approach, which run by processing natural languages without any predetermined template. So far, the first approach has been successful in creating comparable quality of items compared to humans one. However, there is still lack of understanding how to refine, how to get high quality item in terms of the use of unstructured input approach yet. This is something, some direction we may need to move forward. Nowadays, we are utilizing this mixture of approaches. But this study, particularly this study, is mainly focusing on the first one yet. The second key issue of this area is there are different capability of generative AI, large language model, depending on the areas. At the time we investigate this study, the ChatGPT's capability was showing comparable quality for undergraduate level, but did not reach it to PhD questions yet. But as we know nowadays, after release of ChatGPT 5, the capability of generative AI is quite now show very higher accuracy. For example, if you look at mathematics examination, even some model reaches about 100% accuracy in getting answer of that exam. While still the accuracy in answering science question at PhD level is almost get 90% of accuracy, which is quite high. But in health conversation accuracy is not that high yet, about did not reach at 70% yet. So depending on area, the ChatGPT's capability and vary. So we may need to understand how it is capable in creating question and answer. Given those of mind and theories and practices, we have set this question: how do large language model generate question and answer in various STEM subjects in terms of accuracy and quality of working? So firstly, we compare these two models, ChatGPT 3.5 and ChatGPT 4. And question 2 was comparing 3 prompt techniques. The first prompt technique was standard prompting, providing contextual information, including roles. You are, for example, you are a physics teacher. Audience, you are, the question is for year 12 student. Context of question, calculation question for practice, topic, kinematic question, and task. Generate question and answer for this task. This is the first prompt approach at the time. And then second approach was providing instruction to follow per certain step-by-step reasoning. In this case, we put on sample question and answer and let chatbot to follow that structure, reasoning structure, adding on standard prompt. This is the second prompt engineering approach. The third one is mixture of standard prompting, chain of thought prompting, and lastly we ask chatbot to run code in generating question and answer to verify the code. If you have a chance to run a code in the chatbot, then you probably see these kinds of window within your window box. And nowadays, sometimes chatbot can provide this function automatically depending on how they judge, depending on the nature of task received. Third RQ was comparing 3 different STEM subjects involving chemistry, physics, and mathematics respectively, having 2 subtopics. Lastly, we qualitatively analyze what was the common feature of error found in generating question and answer. This is an example of generating question and answer. We put prompt, and we can get a set of question and answer, and we ask chatbot to generate more question and answer. And we analyze this pair of question and answer in total of 600 pairs of question and answer involving 3 different subjects and involving 2 different large language models and 3 different techniques. And for this, we utilize this developed rubric to analyze quality of question. We analyze the clarity of the question and context accuracy of the question. And to analyze answers, we checked final answer accuracy and quality of working. And we gave each set 2 marks per each criteria. This is the result from the first RQ. As we expected, the recent model outperformed previous model. If you're focusing on generating question, then you can see ChatGPT 4 outperformed ChatGPT 5. If you look at answer bars, then you can also see the significant improvement performance of ChatGPT 4 rather than ChatGPT 3.5. We compare the 3 different prompt techniques, showing that chain of thought with coding language outperformed the other 2. While there is some of the lack of full accuracy in chain of thought in generating final answer accuracy. I will elaborate this more next slide. This is from RQ3. We expect that there are small differences across these three different subjects, but there are some differences indeed. One thing is there is very low rate of accurate response from physics question. Then we took a look more closely. One of the questions being used in the generation process was related to projectile motion. If you see this context of the question, which involved there is two critical logical understanding of the concept. One is how many significant figures utilized for calculation within multiple step calculation. And second one is involving how to dealing with two-dimensional coordination from this written form of text. So there's a lot of error happening in these types of questions, so that the result, as result shown, the physics answer was quite lower than the other subject. Here are some of the qualitative analysis from the cases. There is discrepancy between intermediate step and final answer. So the right, this showing the generated question, and this is an example of generated answer, which is quite long. And then this is comment for final answer accuracy, and this is for comment for quality of working. And quality of working is quite, in this case, quite clear, while the final answer was wrong. Let me show another case. This is from chemistry. Quality of working shown partially correct due to error in calculating significant figure. And final answer also partially correct due to this error. Maybe the very slight off of the final answer accuracy. Interestingly, this is quite surprised when I see this result. Quality of working was partially correct, and there's error in calculating significant figure, while the final answer was correct. And this was not the only case. We found some cases within the 600 item generation and so on. So maybe we cannot explain why it happens, as we know. We don't know how actually generative AI create content. But what we know is nowadays there could be discrepancy between this intermediate step and final step. And this is another qualitative finding from this analysis. All these three, because it's targeted to year 12 student, and all include calculation of significant figures. This is one of the common pattern we found across three different subjects. On the other hand, and in subject specifically, there is a redundant information being used, and also there's error in notation for particular axis, missing a formula driving, which is critical in calculation process. And in mathematics, usually we put some logical calculation into our real-life example, but there is unrealistic value used in setting the context of the question. So what we agree with the findings were ChatGPT 4 outperformed GPT 3.5, which is agree. And the second point, COT, chain of thought, quite good in quality, generating quality question. But there's a limitation of quality in multi-step answer by GOT approach, chain of thought approach. The second disagreement from this study compared to the previous literature is there might be identification of dual processing at intermediate step in item generation process. Maybe that would be different between external representation we can see and internal process being done within LLM. Extension, incorporating coding language maybe into COT would be beneficial for us to get more higher quality of question reliably, and then maybe we can also get some idea of how we can differently apply domain-specific prompt rule in get to a higher accurate question and answer. So these are some of the things we identify from this study as implicate those sort of things. Maybe we want to just highlight human-AI collaboration, because due to lack of accuracy, given higher stake exams, then a human in the loop is quite important in this process. This is an example of our application beyond our papers. One of the first author of this study, who is chemistry teacher, generate this website applying our findings of this study. Yes, this is last slide. We are living in the age of generative AI, and we may need to develop our own generative AI literacy. That makes us possible to transform our pedagogy for teaching and learning to better cater education for our students. Thank you very much.